Okay, thank you. So I will give you this presentation about the impact of climate change on global water cycle and the potential role of digital DevNet models in hydrology. Actually, you probably know that I underline in the title et al. Because there are many people working together with me, together with us on these activities. So let's start with the kind of framework. Everybody probably living in Europe, you have heard about this huge storm, the Storm Daniel, in September 2023. And it was quite impressive, both the flooded area that we had in Greece, that is around close to 1,000 square kilometers. That is really huge for this part of the country, of the world. And it's even more worrying, the number of casualties that we had in the Libya, where we had less precipitation, but the conditions were very bad, and 2 dams collapsed, and so we have this huge number of casualties that it's really impressive. Another event that occurred last year in May, of course, I live in Italy, and in that case, 2 storm events basically happened in exactly the same area. The animation on the left shows the precipitation pattern, and you can see that the most important part of the storm is exactly in the same location. And in both cases, we have around 200 millimeters in 36 hours. And to give you kind of understanding, basically what happened in 2021 in Europe with the flood was 150 millimeters in 1 day, in 1.5 days, in 2 days. So basically here, the amount of water falling into this area was really important. And that's why basically we have a flooding that you can see on the top left, top right, lasting for 15 days. And since I started working on this topic in the last 20 years, I never had in Italy having a flooding lasting for 15 days. So what happened in both cases? Actually, probably people doesn't know, but also in Greece, after around 20 days, a storm less important than the Storm Daniel happened exactly in the same area. And so basically we had last year 2 cases in which basically the same storm events occurred twice in 20 days. And people working in meteorology told us that, tell me that basically there is a change in the atmospheric circulation that now is, instead of coming from France, from the Atlantic, now is also coming from the southern part. And so we have these storm events that occur more frequently and also in the same location. And the intensity of the storm is strongly related to the sea surface temperature. On the sea surface temperature, if you were living in Italy last year, and you went to the beach in the summer, basically the water is really hot. I went and I wasn't able to swim because the water was too hot. So what we can do to address, to mitigate the issues related to these flood events? We started developing what we call the Digital DevNet Hydrology project with the European Space Agency. We started 2.5 years ago. And basically, the idea is to develop a prototype of the digital twin for the water cycle. And the most important thing is that we can benefit from high-resolution Earth observation data that are currently available. And the target of this activity that started in the northern Italy in the Po River Basin, but then now we have made the activity for the whole Mediterranean Basin. And the topics that we addressed are basically all the hydrological topics related to flood, to drought, to landslides, and also to water resource management. So now I have a question for everybody. Let's try if it works. If you go on slide.com or you scan the QR code with your mobile, you can go to a link. You just have to write join, and after joining, you can make your vote. And so basically we are talking about digital twin in Europe.
Can you share the link in the chat?
The link.
I can do that for you. I can do that.
Yeah, we will do that. Thanks. Erin will share. Thanks.
But if you scan the QR code, it probably with the mobile is easier. And let's try somebody answer. But the idea here is that everybody is talking about digital twin, and in Europe, but not only. And people say, what is the difference between the digital twin and the modeling that we are doing in the last 100 years? 100 probably not, but 70 years for sure. And so here with this question, you can select, if you want, I wait a bit, what are the main features of a digital twin? Because we are talking, typically we talk about high resolution, to develop an interactive system attached with uncertainty. If it is more important, high accuracy or uncertainty, or if I don't, my screen is a bit, no, sorry. No. And so here, three people answered. I don't know, let's wait. So your vote is, the most important aspect is high resolution time and space, that's important. And interactivity is also the second, and the visualization is the second aspect. Yeah, interactivity and high resolution. These are for me the two main features of the digital twin with respect to what we have now. Because actually we want to develop something that is for which people should be able to interact and to kind of play with the system to make decisions. Yeah, your answer is even in line with what we expect. But consider that all the aspects listed here are important in developing a digital twin. So, what we have? What we have developed, for instance, we have developed by using satellite data, we have developed high resolution precipitation data, 1 kilometer 1 hour for some region. For the whole Mediterranean basin area, we have 1 kilometer 1 day, exploiting the different satellite data sets and merging together. At the same time, and for instance, we exploited Sentinel-1 observation. Here on the left image, you can see the Sentinel-1 image from dark blue means wet area. And you can see that the track, the footprint of precipitation that you can see on the right is quite well reproduced in the Sentinel-1 image. And you should consider that on the right, we have data from radar precipitation. Otherwise, we don't see this kind of track. And so basically with Sentinel-1, we are really able to track the precipitation pattern very well at high resolution. And all these data are available to everybody. We have a company made this system called Earth System Data Lab. In this, the slides will be available for everybody asking, probably the PDF version, because it's a bit lighter. But you can go to the website, to this website, and you can look at the data, you can access the data, you can visualize, you can have a Jupyter notebook to download the data, part of the data. But it's super easy to visualize and to extract the data for your area if you are interested too. Another important aspect that is not really related to flood, but is quite important, is related to high resolution irrigation water use from space. This is kind of very new activities in the last 2-3 years, but now there is a lot of interest in many communities, and we have developed the first data sets for basin in the Mediterranean area. But now the target is to develop this irrigation water use data for the whole Europe and Northern Africa, and then let's see step by step. So I have now a video that basically is showing what we have done. For the whole Mediterranean cycle, we have developed this high resolution data sets, not only precipitation and sun moisture, but also evaporation, snow, and also runoff and gray discharge. And what is new with respect to, let's say, 5 years ago is that the data now that before we had the data at, for instance, daily scale, but 20 kilometer, or we have monthly data at high resolution. Now we have high resolution both in time and in space. And so we have been able to estimate, for instance, here we have the animation of precipitation every day at 1 kilometer resolution for the whole Mediterranean basin. And we have used, of course, this data for several hydrological applications. Here in the video now we have the map of precipitation. But for instance, we can zoom in and go to the flooding occurred at the end of October 2021. That was the flooding called the Medicane. I don't remember now the name, but it's not important. And but coupling with the hydraulic modeling, now we were able to estimate also the flood depth and the flood velocity at very high resolution. Here the simulation is 5 meters. And then the last very important aspect of the digital twin is developing this, what is called the what-if scenario. And for instance, for the polar basin, but I will give you more details in a while. We have developed different scenarios of flood prediction for different input data sets, and we can use this scenario to make future prediction of flood and flooding in the polar basin. And the idea of digital twin basically is to build, to put together the high resolution observation that we have from space, but also ground observation for sure, citizen science, with modeling to address the more and more frequent flood and drought events that we have in Europe. How to visualize the data? We have developed this a platform called the DTE Hydrology platform. And again, on the slide, there is the link. And in the video, for instance, it is shown, we have a 4 button, and the platform is used to visualize the data, but also to investigate what's the scenario for flood risk assessment and for water resource management. The video that is also available online somewhere is provide you some information to use the platform. And basically, it's quite simple because for flood risk assessment, you can select in the boxes the initial condition for soil moisture and the amount of precipitation in the next 10 days. And the system provides you the flood hydrograph at the different points, and also provide the data colored by different colors, because green is okay, and if they become red, we have a flooding. And now we can play with it all together. And no, stop. And so, for instance, this is a scenario that if you put in you can go in the platform, but now we can go live. And if you put 30% of initial soil moisture and 140 millimeters of precipitation, the peak discharge is around 4,400 cubic meters per second. Another question that I made to you is like if you are a flood, you are in an office, you have to make flood prediction in the next 5 days. And if the soil moisture initial condition is 70% instead of 30%, and the same amount of precipitation, I remember you that it's 4,400 for 30% and 140. So what will be if the initial soil moisture is 70%? So again, you can go online, and let's try to play all together. And you can go online, you have to put your name simply because to track the answer. And the same link as before. And you can make your vote. So if the initial soil moisture is 70%, what will be the peak discharge? So soil moisture basically increased from 30 to 70%, and so you have to make an assessment of what can be how much the flood peak will change, will increase or not. And the system is then after the presentation, you can also go online in the platform. It's super easy to be used. And it's also super easy to non-expert to understand basically what will be what is the impact of initial soil moisture and precipitation for flood prediction, for instance, in the Po River Basin. And but just one person joined the quiz. I can wait for a while. Don't be shy, because I don't see the people, so I don't know if I see that just two persons. One is me, and the other one I don't know who. Don't you want to play?
Is it the same link slider as?
Yes, in the same link as
Yeah,
before.
I typed in slido.com and then started typing Brocca and it came up right away. So it was very easy to find.
It's even easier if you scan with the mobile. Well, nobody is happy to play. Well, let's stop now. So, and so I can give you the to answer. Oh, I made the wrong answer. So the one who replied was good, and presentation is working, not as an expert. But then let's see. Okay, one correct answer. Who replied was very good. And actually, if you go in the platform and you put in the number 0.7, you can see that the peak discharge is 7,100. So basically, the platform can be used for showing different scenarios for flood risk prediction. Then you have also a scenario for water resource management. I will not go in details on that because of question of time. But here again, you can select a different scenario for initial condition and for future precipitation and night temperature. And the system provides you an assessment of the water uses of the Po River Basin. Very important to understand. For instance, if in the next summer we can have a restriction for water, like for instance is happening now in southern Italy. But there are several challenges to be addressed. I will not go too much in details because there is not too much time, but I listed the 5 most important challenges that we are addressing in several projects with the European Space Agency, but also European Commission. And this problem is the actual resolution of the data, both from satellite data and from modeling. Most of the time you have model that would tell you that they are high resolution, but actually the falsing, for instance, is 20 kilometer. And so basically also the model should be around 20 kilometer. When you put many data together, you have to understand that the consistency versus the independency of the data is very important. You shouldn't use data that are consistent. They should be independent when you use the data into the model. When you go to high resolution, the human processes and the physical processes become more and more important. So now many people say that we are able to estimate to have a digital twin of the Earth at 1 kilometer resolution. It can be okay for the atmosphere, but when you go when you want to simulate land processes, it's a bit much more challenging. Then how to build a model and how to visualize and to build the infrastructure for the model is some other points. For instance, an example for the resolution. I mean, we just wrote a paper, and in this slide you can see on the left precipitation data for 11th of July in Italy, and on the right you can see the footprint of the precipitation on the ground from 6 different satellites and master product, and except John Murray.
Yeah, Luca, could you back up for just a second? Because I was looking at those categories, and it struck me. We're trying right now to upgrade the the flood tool tracker, and trying to decide which tools to use for which applications. And if you could back up to your previous screen, it's really quite germane. For my colleagues, I don't see it backed up just yet, but the previous screen where you had listed can you hear me, by the way?
Yes, I can hear you. But I'm not on the. I don't know which slide do you want to see.
You had a slide previous to this one that I'd like to see, which had the bands across that had the different
I
categories.
think the challenges slide. That challenges slide that you
Yeah,
had.
that's it. I'm sorry. Yeah, please forgive me. I was actually so excited about it, I forgot the title. But in all of these different categories that you have listed here, these different 5 categories: spatial temporal resolution versus sampling. I mean, these are different considerations that are highly important for end users of flood modeling and mapping tools. And so I just would like to maybe for the purposes of our effort to upgrade the flood tracking tool, this could be part of our decision tree. I think we could potentially work this into our decision tree that we're trying to develop right now to assist users when they go to the site to be able to choose the most applicable tools for the particular application that they are trying to address. Whether it's pluvial flooding or it's storm surge flooding, or it's there are different concerns, and sometimes you weight resolution more over sampling, sometimes you weight consistency of observations or data over independency, etc., all the way down the line there. So this is an interesting perspective. I just want to ask my colleagues who are assisting us with the flood tool tracker to perhaps bookmark this, and we'll discuss it with our technical team. So thank you, Luca. And I didn't mean to take that much time, but this is a really important perspective in trying to utilize flood tools.
Of course, I do agree. And yes, some important aspect listed here is can be also important to categorize the different tools that we have online and the different systems. And by the way, I'm also available if we want to discuss together about these kind of things. But now, just quickly, I wanted to provide you some. Oh, presentation is not moving. Yeah, some example. This is one example. So, for instance, you can see on the right, we have, apart of the last one on the bottom right, all the other products should be 1 kilometer. But if you look at the maps, just looking at the map, you can see that the 2 in the top basically provide a quite detailed map that is very close to precipitation, and probably this is really 1 kilometer. The second on the top right, probably there are some noise, but still 1 kilometer. But if you look at the other 3 products, particularly the SMAP Planet or SMAP, and also this one, they are not really high resolution. The pattern looks much more smoother. And so basically, if you download the data, they say that they are 1 kilometer. But if you look at the pattern, probably this is not the case. And the same example we can have also for modeling. And so basically, when we use the data, we should be aware of the actual spatial and temporal resolution. And this is a problem because everybody is talking about high resolution modeling, high resolution data, but sometimes the data have not the resolution that is claimed for. Consistency versus independency, this is a quite complex diagram, and this is complex by purpose because these are in one of the projects with the European Space Agency, we developed different data sets for precipitation, vegetation optical depth, you can see high here, radiation, evaporation, river discharge, soil moisture. And this product in brown, basically, these are based only on one satellite sensor. and it's okay. So all of them are independent. Then we have some modeling, and when we have some modeling, we are able to estimate other data sets that are based on the integration of satellite data and model. But if you look at the different lines, it's quite chaotic, and it means that the number of interconnection between the different data sets is really huge. And so, for instance, if you look at gleam evaporation and CELMOST, basically this is more the results of a model integrating several satellite products than a satellite product itself. But if you consider gleam, it's typically considered as a satellite-based evaporation product, but it's probably most modeling. And the same, it happens for snow melt, for interception, and other data sets. So again, the consistency of the data sets with respect to independence should be really checked. And then finally, another diagram, quite complex, because for instance, for flood risk, you can see all the boxes here where we have a satellite is a partner, is a group developing the product. So for instance, for precipitation, we as CNR will develop the product, surface and muscle from University of Vienna, evaporation from Ghent. And so each of the components has a number of people working behind that. What we did in the digital twin hydrology, we use all this data, and for instance, we start putting the data into the modeling. So for instance, precipitation and snow, and the meteorological data we use in a snow module for computing snow melt. Then snow melt is used together again with precipitation and surface moisture in the soil water balance module for estimating percolation. And then step by step, the different data are used, or at the end, providing information about flood risk. And you can see that there are different components into the modeling system. Each of them requires some assumptions, some equations. And here the question is how to build this modeling system. And the most important idea here is that actually the modeling system is quite complex. Everybody should have access to this. And a modular approach in which all the components are accessible from everybody who want to contribute should be the main way forward. But it's not easy when we start looking at systems that are quite complex. And this is for flood risk. And if you look for water resource management, it's even more complex. So we have developed this prototype for digital twin. We have very recently written a paper in which all the information are available. We wrote also a paper for the young minds. Here I have some screenshot from this paper. It's quite it was quite a nice experience, and you can see again the link on the bottom. But if you want more information on all these things that we have developed, there is the full paper called the Digital Twin of the Terrestrial Water Cycle. The link is on the top, and if you go in the link, there is in this journal what they call a hub, and in the same web page you can see the paper for young minds, the editorial, the policy view, the infographics, the press release, and much more material that you can use and you can explore to have better insights on all these kind of things. Thank you very much. This is my last slides.